So, I want you to picture the edge of a cliff. Just really try to visualize this for a second.
Okay, I'm picturing it.
You are standing there, wind in your hair, looking out over this dark, completely endless ocean at night. And you ask yourself the single biggest question a human being can possibly ask.
Right, the real existential stuff.
Yeah, not what's for dinner or did I leave the stove on, but where did all of this actually come from?
The ultimate origin story. I mean, it's the question that keeps you up at 3 in the morning.
Exactly. And we aren't just talking about the water or the cliff or the earth. We are talking about everything: space, time, matter, energy.
All of it.
Right. And for centuries, if you ask the smartest person in the room, like Aristotle, or even the top scientists of the 19th century, you would have gotten a surprisingly boring answer.
Which was?
They would have told you it didn't come from anywhere. The universe is eternal. It just was.
Right. Which is honestly a very comfortable position to take, philosophically speaking.
How so?
Well, if the universe has always been here, you don't have to deal with the messy question of a beginning. Because a beginning implies a beginner. It implies that something or someone started the clock.
Yeah, it lets you totally avoid the God question. It is just a nice, safe, static bubble. But today we are doing a deep dive into a stack of materials centered on an investigation by journalist Lee Strobel.
Yeah, featuring the work of philosopher William Lane Craig.
Exactly. And the headline from these sources is massive. That eternal universe safety net, it is completely gone. Science and logic have effectively shredded it.
They really have. We are looking at this wild convergence of modern astrophysics and ancient philosophy today, and it points to a very specific moment. The universe actually had a birthday.
So, to get into this, we're going to unpack something called the Kalam cosmological argument. And I know cosmological argument sounds like something you'd need a velvet robe and a PhD to discuss.
It sounds super intimidating, yeah.
It does. But I promise it is actually a deceptively simple logic puzzle.
Simple on the surface, but the implications are staggering. It is one of those things where once you see the logic, you really can't unsee it.
So here is our roadmap for this deep dive. We are going to look at why Albert Einstein, the genius himself, actually fudged his own math because he was scared of a beginning.
A fascinating piece of history.
Yeah. Then we are going to play a mental game with marbles that proves why the past cannot be infinite. And we'll see how imaginary numbers, and that is a literal math term, might be the only place left for skeptics to hide.
And finally, which I think is the most mind-bending part, we will see how the raw data leads to a very specific profile for whatever or whoever started it all.
Let's jump into the logic first. The mission here is to understand the Kalam argument. Where does this even come from initially?
So it is rooted in ancient thinking, specifically from medieval Islamic scholars like Al-Ghazali, which is actually where the name Kalam comes from.
Oh, interesting.
Yeah, but William Lane Craig has essentially modernized it for the 21st century. He boils it all down to 3 incredibly simple sentences.
Lay them on us.
Premise 1, whatever begins to exist has a cause.
Okay.
Premise 2, the universe began to exist.
Right.
Conclusion, therefore the universe has a cause.
That seems, that almost feels too simple. It feels like a basic syllogism you would learn in Logic 101.
It is basic logic.
Let's stress test premise 1 first. Whatever begins to exist has a cause. My intuition says yes. Things don't just pop into existence out of thin air.
Right.
Like, if a horse appeared in my living room right now, I wouldn't assume it just happened spontaneously. I would assume someone put it there, or I'm hallucinating.
Precisely. Craig argues that this is a first principle of metaphysics. It is bedrock reality. To deny it is to deny rationality itself.
Because if things could just pop into existence without a cause, why doesn't it happen all the time?
Exactly. Why don't bicycles pop into existence in your driveway? Why don't root beers just appear in your fridge?
That would be nice, actually.
It would be. But we know that is not how reality works. The source material makes a really interesting, slightly snarky comparison here regarding magic.
Oh, I love that part. He says believing the universe came from nothing is worse than magic.
Worse than magic. Think about that.
Because with magic, you at least have a magician and a hat.
Exactly. You have a source and a potential. Even if the rabbit appears magically, it is coming from the magician. If you are arguing for atheistic materialism that the universe popped into existence from nothing, by nothing, for nothing, you don't even have the hat.
You have absolute zero.
Right. And out of absolute zero, you somehow got everything. As the old song goes, nothing comes from nothing.
But we have to address the elephant in the room here. Or rather, the particle in the room. A lot of you listening who follow science news might be thinking, wait a minute, quantum physics?
Yes, the quantum vacuum objection.
You hear this all the time, that in a quantum vacuum, particles pop into existence spontaneously. It is cited in pop science articles constantly. Doesn't that prove you can get something from nothing?
That is easily the most common objection Craig faces, but he argues it is based on a linguistic trick. It is a fundamental misunderstanding of terms.
How so?
When physicists talk about a quantum vacuum, they are not talking about nothing in the philosophical sense.
They aren't talking about absolute zero.
Not at all. A quantum vacuum isn't an empty void. It is a sea of fluctuating energy. It has a physical structure. It is governed by physical laws. It is very much something.
So it is like an invisible soup that boils occasionally.
That is a perfect analogy. And if particles are popping out of that soup, the soup itself is the cause. The energy fluctuations are the cause.
So you haven't actually explained the origin of the universe.
No, you've just pushed the question back one step. You still have to explain where the quantum vacuum came from.
Okay, so premise one holds up. Things that begin need a cause. You can't get a free lunch, cosmically speaking. But the real battleground in these sources is premise two. The universe began to exist.
Because for thousands of years, people thought the past was infinite.
Right. Why can't we just say the universe goes back forever?
This is where things get really trippy. We have to distinguish between a potential infinite, which is just an idea, like counting 1, 2, 3, forever. Sure.
And an actual infinite, which Craig argues cannot exist in the real world.
This is the mathematical pathway part of the sources, and they use a marbles analogy here that completely broke my brain. I want to walk through this because it forces you to realize how weird actual infinity is.
It exposes the absurdity of it. Okay, visualize this with me. Imagine you have a physical sack of marbles.
Okay.
But it is not just a big sack. It is an infinite sack. You have an infinite number of marbles in your possession.
All right. I have the pile. It is heavy, presumably.
Infinite weight, yes.
Yeah.
Now, I want you to give away all the odd-numbered marbles. 1, 3, 5, 7, and so on. How many marbles did you give away?
Well, the odd numbers go on forever, so I gave away an infinite amount.
Correct. Now, look at your pile. What do you have left?
I have all the even numbers. 2, 4, 6, that also goes on forever. So I still have an infinite pile.
Right. So mathematically, you have infinity minus infinity equals infinity. You subtracted an infinite amount, and the pile didn't shrink at all.
Okay, I'm with you so far. It is weird, but I get it. Now, reset the pile. You have your infinite marbles again. This time, I want you to give away all the marbles numbered 4 and higher. 4, 5, 6, 7, on to eternity.
Okay, I am giving away an infinite amount again.
Look at your pile. What is left?
Just marbles 1, 2, and 3.
Exactly. So in this case, infinity minus infinity equals 3.
Whoa. Okay, stop. That shouldn't be possible.
Why not?
Because I subtracted the exact same amount infinity both times. But in one case, I have a bottomless pile left, and in the other, I can hold the remainder in one hand.
That is exactly why actual infinity is banned from the real physical world. It leads to logical contradictions. You get different results by subtracting the exact same amount.
So you cannot have an infinite number of past events.
No, just like you can't have an infinite pile of physical marbles. It breaks logic.
There is also the issue of traversing the infinite, right?
Yes.
The sources mention this as the counting problem.
Yes. Think of it this way. To get to today, the universe had to pass through yesterday, and the day before that, and the day before that.
Makes sense.
If the past is infinite, if it goes back forever, you would never, ever reach today.
Why not?
Because you can't finish counting an infinite number of days. It is like trying to jump out of a bottomless pit. No matter how long you climb, you never find the edge.
So if the past was infinite, today would never actually arrive.
Exactly. But today is here. You and I are talking, so the past must be finite.
Logic dictates the universe had a start date.
That is the philosophical proof. But logic is one thing, hard data is another. This brings us to the scientific pathway. And this is where the story gets really dramatic.
Because it involves the biggest celebrity in science history, Albert Einstein.
Yes.
I was honestly surprised to learn that Einstein, arguably the smartest man in history, was effectively an eternal universe guy.
He was very much a product of his time. In 1915, when he developed the general theory of relativity, his own equations were screaming at him. They showed that the universe was not static, it was unstable. It was either expanding or contracting.
But he didn't like that.
He hated it. He found the idea of a dynamic universe irritating. Those were his actual words. Because a moving universe implies a beginning, and a beginning implies, well, what that implies, it implies something outside the universe created it.
So he fudged the math.
He literally did. He inserted a symbol into his equation called the cosmological constant.
Just completely made up.
It was basically a made-up factor to force the equations to stay balanced and static. He put a mathematical parking brake on the universe to keep it from moving.
That is wildly humanizing. Even Einstein cooked the books to fit his worldview.
It happens to the best of us. But he couldn't hold back the tide of evidence for long. Enter Edwin Hubble.
The man with the telescope.
In the 1920s, at Mount Wilson Observatory, Hubble completely shattered Einstein's static universe. He looked through his telescope and observed that the galaxies are flying away from us.
The redshift.
Right. It is like the Doppler effect with sound. You know how a siren sounds lower pitched as it drives away from you? Light waves stretch out and look redder as they move away. Hubble saw red everywhere.
Meaning the universe is exploding outward.
Expanding rapidly.
The sources use the movie analogy here, which I think is just the best visualization. If you film an explosion, debris is flying everywhere. But if you hit rewind on the remote,
Everything moves backward, the galaxies get closer and closer, the universe gets denser and hotter, until finally you go back 13.8 billion years, and everything converges into a single geometric point.
the singularity.
Infinite density, infinite heat. And this is the crucial part. It is not just matter that is compressed. It is space and time itself.
Wait, space itself?
Yes, there is no outside the singularity. There is no before the singularity.
That is so hard to wrap your head around. It is not an explosion in space. It is an explosion of space.
Correct. And if Hubble wasn't enough, we found the literal smoking gun in 1965. Penzias and Wilson.
Oh, the guys who thought they had bird poop on their antenna.
The very same. They were researchers at Bell Labs trying to use a super sensitive radio telescope, but they kept picking up this annoying static noise.
And they tried everything to get rid of it.
They scrubbed the pigeon droppings out of the horn. They checked the wiring. They pointed it at New York. They pointed it away from New York, but the noise wouldn't go away. It was coming from everywhere in the sky, day and night.
And it turned out to be the echo of the Big Bang.
Cosmic microwave background radiation. It is the remnant heat from that first moment of creation still cooling down. It sits at about 3.7 degrees above absolute zero. It was exactly what the Big Bang Theory predicted we would find.
So you have the math showing no infinite past.
Hmm.
You have the expansion from Hubble. You have the heat signature from Penzias and Wilson, plus the abundance of light elements like helium and deuterium, which the sources note could only be cooked in the furnace of a Big Bang, not inside stars.
All of it aligns.
The verdict seems completely unanimous. The universe began.
It did. And this forced a massive shift in the scientific community. For a century, the skeptics were the ones defending the eternal universe. Now, they were backed into a corner. They had to explain how a beginning could happen without a beginner.
Which leads us to the wiggle room section of our deep dive. Because if you are committed to a worldview where there is no God, the Big Bang is... The text literally calls it repugnant to some scientists. It sounds way too much like Genesis chapter 1.
So we saw a huge scramble for alternative theories, models that could accept the new data but somehow avoid a definite beginning. You had the steady state theory for a while.
That is the idea that matter is constantly being created out of nothing to fill the gaps as the universe expands, right?
Yes, but it violated the fundamental laws of physics and had absolutely zero observational evidence. It died pretty quickly. Then you had the oscillating model, the big crunch.
The breathing universe. It expands, stops, crunches back down into a tiny point, and then bounces out again. Forever.
It sounds plausible at first, but physics killed it too. Two main reasons. First, there is no known mechanism in physics to make a universe bounce after a crunch. It would likely just collapse into a black hole and stay there.
And the second reason.
Entropy. The second law of thermodynamics. Even if it could bounce, some energy is lost every single time. It is like a bouncing ball. Each bounce is lower than the last.
Okay, I fall.
So if you look forward, the bounces get smaller. But that means if you look backward in time, the bounces must have been bigger.
So they get bigger and bigger as you go back, meaning you still eventually trace it back to a first original bounce. You can't escape the starting line.
Exactly. The bounce doesn't save you from a beginning. But there is one more model we need to discuss because it involves Stephen Hawking. He proposed a model that tried to erase the singularity entirely.
This is the cone versus shuttlecock visual from the reading.
Right. The standard Big Bang model looks like a sharp cone. it narrows down to a distinct, sharp point at the bottom, the beginning. Hawking proposed a model that was rounded at the bottom, kind of like a badminton birdie.
So if you travel back in time, down the side of the birdie, you don't hit a wall. You just curve around the bottom smoothly and keep going. No sharp beginning point.
That was the idea. But Craig points out a fatal flaw in how Hawking built this model. He achieved that smooth curve by using imaginary numbers.
Now, when you say imaginary, you don't mean fairy tales. You mean the literal mathematical term.
Yes. The square root of -1, lowercase in equations.
Okay.
It is a totally valid mathematical tool, and it is very useful for calculations. But it doesn't necessarily represent physical reality. It is a bit like a map projection. You can flatten the round globe onto a flat piece of paper to make it easier to read, but that distorts the reality of the actual sphere. Hawking admitted that his model operated in imaginary time.
And the sources say that when you convert his model back into real-time, real numbers, what happens?
The sharp point comes back. The singularity reappears immediately. Even with the most advanced mental gymnastics, the beginning stands firm. The universe has not been here forever.
So let's take stock of where we are. We have a universe that definitely began. We have a logical proof that it couldn't have been eternal. This brings us back to the Kalam argument, step 3. Therefore, the universe has a cause.
And here's where we put on our detective hats. We can't exactly put this cause in a test tube, but we can deduce its profile based on the evidence we just went through. We can build a suspect profile.
Let's build it. If this cause created space and time, it can't be inside space and time.
Right. It must transcend them entirely, so it must be spaceless and timeless.
It created all matter, so it must be
immaterial, non-physical spirit, essentially.
And to create the entire cosmos from absolute nothingness.
Unimaginably powerful.
Spaceless, timeless, immaterial, powerful. That is a very specific list. It is starting to sound exactly like a theology textbook. But here's the part that I really wrestled with in the notes. Why does it have to be a person? Why can't it just be a force, like a supergravity or some quantum electric charge we just haven't discovered yet?
This is easily the most subtle and powerful point in the whole deep dive. It comes down to the fundamental difference between a mechanical cause and a personal cause. Craig uses the tea kettle analogy to start.
The tea kettle.
Yeah. If I ask you, why is the kettle boiling? You could say, because heat energy is agitating the water molecules. That is the scientific, mechanical explanation.
Right.
Or you could say, because I put it on to make tea. That is the personal explanation. Both are totally true.
But the personal explanation explains the origin of the event, the intent.
Exactly. But let's go deeper, because the frozen water analogy explains the mechanics of why the cause literally has to be a person.
Okay, walk us through the frozen water.
Imagine the cause of the universe is just a mindless, mechanical set of conditions. Let's say, for the sake of argument, the mechanical cause is simply the temperature being below 0 degrees.
Okay, so the cause is the cold.
Now, if that mechanical cause is eternal, if the temperature has always been below 0 from eternity past, then what happens to the water?
It would be frozen, always.
Exactly. If the cause is sufficient and eternal, the effect must also be eternal. You cannot have an eternal freezing temperature, and then suddenly, just 13 billion years ago, the water decides to freeze. It would have been ice forever.
I see exactly where you were going. If the cause of the universe was just a mindless force, and that force was there forever, the universe would have been here forever.
Yes, the effect would coexist infinitely with the cause, but we know the universe is not eternal. It is a temporal effect. It started 13.8 billion years ago.
So how do you get a temporary effect from an eternal cause? How do you get a new beginning from something that has no beginning?
There is only one entity in existence that can do that, an agent, a person with volition.
Free will.
Exactly. A man can sit eternally on a chair, but then choose to stand up. The state of sitting is eternal, but the action of standing has a beginning. It requires a decision. I choose to create now.
That is wild. You're deducing personality and will just from the concept of time and causality.
It shifts the conversation entirely. We aren't just looking for a battery that powered the Big Bang. We're looking for an architect. We are looking for a mind.
This moves the needle from abstract philosophy to something that really hits you in the gut. And the source material includes a story that really illustrates this human impact. It is about a physicist from Eastern Europe that Craig met.
Yes. This part of the investigation was incredibly moving. She was a brilliant scientist, but she described her worldview as darkness within and darkness without.
That is heavy.
It is. But she saw the universe as a blind, meaningless machine, just atoms banging against atoms. which is a very honest place to be if you are a strict materialist. If it is all random, none of it actually matters.
But then she read Craig's dissertation on the Kalam argument.
She did. And because she was a physicist, she understood the data immediately. She knew the Big Bang was real, she knew about the expansion, but she'd never connected the philosophical dots that a beginning requires a beginner.
The text says she had a spiritual awakening right there in the physics.
She did. She realized that the laws of physics she studied so intensely were actually evidence of a lawgiver. There is a beautiful moment where she holds a pamphlet on spiritual laws and says, physical laws, spiritual law, this I can understand.
It completely bridged the gap between her head and her heart.
And that is the true utility of the Kalam argument. It is not just a clever logic trick to win debates. It validates the deep human intuition that we are not accidents, that there is actual intent behind the cosmos.
It really flips the script on how we talk about this stuff. We used to think that to be scientific meant you had to reject the idea of a creator, that faith was just for people who didn't understand how the physical world worked.
Now, the tables have completely turned. The believer stands firmly on the solid ground of the standard model of cosmology, the Big Bang, the expansion, the thermodynamics. It is the atheist who has to do the mental gymnastics.
Inventing multiverses we can't see, or imaginary time.
Just to avoid the natural conclusion that the universe was made.
It puts the burden of proof squarely on the skeptic to explain how everything came from absolutely nothing without a cause.
And mathematically and logically, that is a very heavy burden to carry.
I want to leave you, the listener, with a final thought to mull over as we wrap up. The argument we covered today gets you to a creator, one that is timeless, spaceless, powerful, and personal. But as Craig himself points out in the sources, it doesn't necessarily tell you the name of that creator. It gets you to a creative force with a will.
True. It is the first step. It gets you to monotheism, but it doesn't get you all the way to a specific religion's text.
But it raises a really provocative question. If a being had the power and the will to create a universe of this magnitude, billions of galaxies out of absolute nothingness, is it logical to assume the being simply walked away?
The old clockmaker theory, that God wound it up and just left it on a shelf.
Right. If you go to the trouble of building the most complex machine imaginable, do you just abandon it? Or, if there was a specific intent to create a world like this, is that being still active in it?
It's a great question. If they lit the fuse, maybe they are still watching the fireworks.
Definitely something to think about next time you look up at a clear night sky. The darkness isn't empty, and the beginning wasn't an accident. Thanks for diving in with us.
Always a pleasure.
See you on the next Deep Dive.